Okay, welcome back. This is part two of Production Rust, build a GraphQL server. So in this part, we're going to make things a little bit more interesting and start to lay down some of our GraphQL schema. We're also going to take that schema and we're going to build an endpoint within our HTTP server that can listen for requests. And finally, we're going to create a playground where we can fire off those requests and see the response coming back. So there's a few different parts to this video. As always, please do follow along or pause the video later and physically type out the code that I'm typing to get a feel for what we're putting together here. So what I'm going to do now is dive straight back into Cargo TOML, and we're now going to bring in the GraphQL specific libraries, the libraries that we're going to use to be able to send requests, interpret requests, and send back responses. Okay, so we're going to open crates.io again, and this time we're looking for the async GraphQL library. Okay, and we're just going to grab the latest. And so this piece is the main library itself. This is what allows us to execute queries against this server that we're building. And the second piece is going to be async GraphQL warp. And this is the integration layer, the bridge between async GraphQL and our warp web server. So we're also going to bring that piece in. Okay, so with those two pieces in place, we're going to go back to our source code. And again, thinking in terms of domains, what are the almost physical pieces that separate the concepts within this application? So we've got a web server now, and we'll start building out the GraphQL pieces, which are going to be distinct. They're not necessarily tied to the web server, even though there's the kind of that middle interim piece that kind of ties the two together ultimately. So we're going to say new Rust file, and we're going to call this one schema. And as before, we're going to create a mod and attach that to main RS. So you can see there then that's being attached to the parent scope. Okay, so what we're going to do now is start building our schema. So the way that GraphQL works is essentially it's a giant graph, as the name would suggest. So on that graph, there are going to be individual fields, and within those fields, sometimes scalar values are returned back. So simple things like numbers, like strings. Other times, objects are returned, which each contain their own fields. And the way that we can lay this out, there's a couple of different strategies within async GraphQL. We can use simple structs to kind of resemble or reference our particular shape of response. And so we can simply send those back, and the user, the client, can request just the fields that they're looking for and get those exact fields back in the response. So there's no underfetching, there's no overfetching. So that's strategy number one. The second strategy that we're going to start with in this video is using functions to resolve fields. So what that means is a user will request a field, and it will actually be a Rust function, or rather a method on the struct, as we'll see, that is executed, and that contains the logic that's necessary in order to formulate that response and get that back to the client. Okay, so at the very root of the graph, the GraphQL graph, is a concept called query. Okay, so there are actually three distinct types within GraphQL. There are queries, and you can think of those as almost like HTTP GET requests. So those are things that we ask for, and we can provide parameters and various different things that modify what we get back. But ultimately, they are things that we get back from the server. Then there are mutations, and as the name suggests, that's pieces of information that we want to change. So if we have an endpoint, let's say for logging in a user, presumably something physical is going to happen there. The database is going to be queried, certainly, but if we actually physically log in the user, maybe we're creating a session object, persisting that to the database, something like that. So it's changing something, and that's where the name mutation comes in. So they operate very much like queries. We'll get into them more specifically in a later video. But that's the second concept, mutations. The third is subscriptions. And a subscription is where we literally subscribe to a query. And as the data changes, we can get back new payloads representing that change. So let's say we have a classic example of a stock ticker. Maybe we'll subscribe to a particular stock symbol and we get updates back, maybe at 5-10 second intervals or whatever the particular parameters or logic of the application is. We get those payloads back to show us the latest stock price. Okay, so we're going to start with the very basics. We're going to start with queries. So what does a query look like? Well, first of all, we have this root query object. So I'll create this struct and I'll literally call it query. And what we're going to put in there, essentially all of the different pieces of the graph that make up a query. Okay, so in order to do that, I think it's probably best, like before, like in the first video, where we start with the end in mind and we think about what we actually want to feed into this main query object. So what I'm going to do is I'm going to mimic what we've already got in the web server, and that's that health endpoint. So I'm going to call this health, and we want to attach that to our mod, make it available. And so what we're going to do within that health endpoint is very much the same as before. It's a request that we can make to the server where we get back this true response that says, yes, the server is alive. Okay, so we'll build that piece out first. So when we're thinking in terms of domains of our application, we're certainly thinking in terms of GraphQL being a distinct piece from the server. But also within GraphQL, we're thinking of pieces of our graph being distinct portions of the graph. So in this case, what we want to do, we'll create a public struct, and this is going to be attached to the query root object ultimately. So we'll call this health query. Okay, and all I'm going to do as well, I'm just going to derive the default functionality there that provides us with some boilerplate to the health query so that the GraphQL can orchestrate that and turn that into an object that actually requires in order to have fully fledged schema. So we can just leave that to the Rust compiler to do its work. Okay, so now what we want to do is basically implement this health query. And as I mentioned, there are a couple of strategies. We can have an object that has data on that and send that back to the user, or we can have a struct that has methods on it, and those method names become the fields. So this will all make sense when we fire up the playground and we take a look at the end result. So what I'm going to do is I'm going to use the latter of the two methods, and so we're going to implement a method on health query. Okay, and this is going to be an async function. This is an async GraphQL library. So nice thing about that is all of the resolvers are asynchronous. So if we need to do things where we've got asynchronous functionality within it, calling out to a database, reaching a network endpoint, whatever it is, the GraphQL server will handle scheduling of all that along with the async runtime, and it will wait until that information is all available until it's sent back to the client. So that's very, very useful to us. So we'll call this health, much like before, and all of these methods within the struct are going to take self. And in this case, we just want to mimic what we're sending back in the web server. So if you remember, we'll jump back to the server, look at our roots. You can see we've got this OK true. I will basically just going to return this true portion. So what I'll say is this returns a bool. Okay, and literally that's just going to be true. So we're going to basically invoke this method whenever someone requests the health field of the root object. Okay, so let's just add a little bit of dot commentary to this to say returns, what should we say? We'll say returns true to signify that the GraphQL server is reachable. Now, within async GraphQL, once this gets compiled and this becomes part of our public API surface, one of the nice things that async GraphQL does for us is it takes these dot comments, these vanilla Rust dot comments, and it turns them into descriptions for our public endpoint. So we're actually going to be able to see this within the playground very soon. Okay, so this is a very minimal example of what we need to start building our query graph. Now we just need to do one more thing. Up here, I'm going to use async GraphQL, and I'm going to grab the object. And what I'm going to do is I'm going to annotate that with object. So this at compile time is going to inject a bunch of boilerplate that turns our health query into something that's resolvable. So this is basically going to be a full graph, and then the health method becomes a field on that, as mentioned. Okay, so this is, as you can see, 12 lines of code, very, very minimal. All it's going to do is return true when health is requested. So now what we need to do is we need to jump back to mod, and we basically need to feed that into our query. So there's a couple of things, first of all, I'm going to do here. So I'm going to use async GraphQL, and I'm going to bring in something called a merged object. And I'm going to annotate that here. So I'm going to say derive, and I'll say merged object. I'll also derive default because we're going to need that to build the full graph. You'll see in just a second why we need that. So what merge object provides us with is the ability to stitch together disparate parts of our graph into one unified graph, one unified schema. So that way we can namespace things. So we've got this health, we can build on that, we can have database calling methods, we can have other parts of our application, other concerns, and stitch them together into this top level query. So what I'm going to do is just provide that health query, and this is our only piece at the moment. So we're not actually stitching things, but we're using that merge object to anticipate the need to do that a little bit later. Okay, so now we have the query. What we need to do is we need to take the query and we need to take our non-existent mutations, our non-existent subscriptions, which will be defined in later parts of the course, and we need to merge them together into a giant schema. Okay, so what we're going to say here is we'll just say build the GraphQL schema, and we want a function that's going to build that schema and return it back to us. So we know this is going to be public, so we'll just add that public modifier. The reason it's public is because we're going to take this, we're going to run this, execute it, and use that to inject into our server and power our server. And we'll call this build schema. Right, so what's this thing returning? Well, this is going to return something within async GraphQL called a schema builder. So schema builder. And basically, it's a way for us to start building the schema, and we can do this piece by piece. And ultimately, then we finish building the schema. We get a complete schema. We inject it into our server. So you'll see how that works. So this is going to be a schema builder, and this takes, look, you can see here 3 parameters. So those parameters are, first of all, query. So we'll make sure, actually we don't need query there, we've already got it here. So this is going to be a completed query. The second thing is going to be our mutation. So if we had a mutation, a struct mutation, we could provide that in as well. We don't at this point, we haven't defined anything, but we still need to put something there. There's no way currently within Rust to be able to use default parameters. So what we need to bring in instead is something called an empty mutation. You can see from this IntelliSense provided to us by CLion that we're already, kind of one step ahead. We're already going to have a subscription and a mutation, so you can see where this is going. So I'll put those both in just in anticipation of that, because we've got no mutations, we've got no subscriptions, but we still need a complete schema builder. Okay, so that's that piece. So now what we want to do is we actually want to build the schema. So another thing we're going to be bringing in here is this this schema object, and so we're going to say schema, and then we're going to use the build method on that, and we're going to feed in our query. So this is going to be query default, so this is where the derived default comes in. And of course, because something that's derived as default, all of its fields, all of the information within the struct also needs to be default derivable, which is why on the health query we did the same thing there. Okay, so we're building our query there, and here I'm just going to provide that same empty mutation and empty subscription because we don't have anything to offer at that point. Okay, so this is where it gets a little more interesting, because what we're going to do is we're going to merge the 2 worlds, GraphQL and Warp, the web server. We're going to mash them together so that we can get queries publicly on our server and execute them within GraphQL and send the response back. So What we're going to do is we're going to be working within server routes, and it's basically this piece. Remember in the last video, I said we're going to be composing routes. So that's essentially exactly what we're going to do at this point. So up here, in anticipation of needing our schema, I'll say use create schema. And maybe at the top here, we'll say, we'll just add a little space there. We'll say build the GraphQL schema. Okay, so we want this complete schema, this full schema to be working with. So what we'll say is schema and build schema. So you can see there I'm shadowing this piece. We're not going to need it after this point. This is absolutely fine. And as it returns a schema builder, we can compose this. We can kind of keep doing methods, requesting methods, adding data and things like that. When we start adding data and injecting that into context so it's usable within our resolver methods, you'll see where this comes in. We can also do things like disable the introspection, so it prevents clients from being able to see kind of the shape of all of the available API responses. But all we want to do at the moment is run finish, and basically this is going to compile our schema, and you can see we get back then our full schema object. Okay, so we're going to keep our health endpoint in place here, but further down what we're going to do is we're going to create a GraphQL handler. So we'll say GraphQL query, and to be honest, it's also going to be a subscription handler. We're not going to do the subscription piece at this point, but I will leave that kind of there as a placeholder so we know this is the piece where we augment with subscriptions a little bit later. Okay, so we're going to say let GraphQL handler, and this is going to be a warp handler in much the same way that health is. We want to be able to respond to HTTP post requests. So that's the HTTP method of receiving a query mutation or a subscription from a user, and we're going to then send them a response back. So in order to do that, we'll say warp and post. So this is going to be distinct from get or head or delete or other REST-like methods. And once we have that post request, we're going to say and. This is how we compose things in Warp. So it's kind of opened a post. We also want this to respond on the path GraphQL. So this is going to be the endpoint that it's mounted on. And within that, we're going to say and as well. So you can see how these little pieces are composed together. So within that, we're going to say async GraphQL. And it's actually async GraphQL warp, I believe. So this is the bridge piece. This is the piece that's going to connect async GraphQL warp to the rest of GraphQL. And so we're going to open this GraphQL method, and this is going to take that schema that we've just built up top. Okay, and so this is then going to open an and then block, and what we're going to provide here is a method, and so we're going to give it this kind of closure where it's going to receive a schema and a request, and that we need to just annotate with types because the type system is going to get a little bit confused if we just have these kind of anonymous types. So what we'll say is this is going to be of type schema, and I'll bring these types in just a second so you can see exactly where they go. And we're just going to leave it for the compiler to discern what those types are. It's going to be the same as these types here, but we don't want to definitively supply them. So we just use these underscores, and it's going to know how to figure that out. And this is going to be a request. So this matches both the schema and the request. Okay, so we'll just close that off. And before we move on, I'm just going to do an async move. Because what's going to happen is this function itself is asynchronous, but we want to be able to move what we've got from this closure into this block, hence async move. Okay, so I'm just opening this, and this is where we're going to continue from. But for now, you can see we've got these errors because none of either the schema nor the request is currently in scope. So where do we get those pieces from? Well, if we head up to the top, we'll just make it clear. So we'll say async GraphQL, and here we're going to get request and schema. Okay, so if we save that, this should turn black and we should be good to go. Right, so just checking that I've entered everything properly there because I've got this red. No, I haven't. So I've closed this this closure parameter block off. I'll get rid of that because you can see it's actually there. We're annotating we're defining explicitly the types that we should receive within this closure here. So this needs to wrap the full thing. Okay, so that's looking pretty good. We'll also add the semicolon at the end to terminate the statement. So within here, basically at this point, what we're saying is we have a request on the GraphQL endpoint, okay? It's a post request. The schema is known. It's been injected into GraphQL Warp, so it knows to do the translation from the JSON that it's receiving down into the async GraphQL library. We now need to execute it. Okay, so what we need to return within this block is actually a result. So we're going to say okay, and we're going to provide a type here. And again, just because we don't exactly know the type, we're going to leave this for the compiler to figure out. So we're just going to use the underscore there to tell the compiler to go look for it, to go do its thing. And there's no way that this can fail because we have a definitive schema. So this is actually going to be an infallible result type. And you can see if I just hit enter, it should just bring that in for me. Okay, so we've got an infallible type. And we're going to open this up. And what we need now is a GraphQL response. Now this is distinct from a warp response. There's a method within warp called or a type within warp called response as well, but this is going to be distinct. So we actually want to call this out as being specific to GraphQL. So what we're going to do is call that async GraphQL warp. This is where we're pulling it from. And what we'll say is we want with response within it, but anticipating that we're going to have a clash of the name with the warp version of that. We'll call that one as let's do GQL response. Okay. So this is what we need to use within this this block. And so what I'll do here is I'll say GQL response, and if we open that up, you can see some methods from. So this is going to take a response from the schema with a schema that we're executing against, and we're providing that request object that's being fed in. So async GraphQL Warp is doing the bridging between Warp and GraphQL as mentioned. One of the things it bridges is the actual request itself, and it's provided now something that the GraphQL, the async GraphQL is able to work with. So it's taking it from that kind of HTTP post payload into something that it's ready to work with. And within here, we want to await that. Okay, so that should be the GraphQL handler. Not seeing any compilation errors. This is a little bit involved. So this is one of those areas where it's once it's done, it's done. We don't really have to revisit it. We will revisit once to be able to inject in subscription support, but then we can kind of leave it alone. And that's what's nice about this. Once we've figured out these kind of intricate pieces, we can move on and get into our business logic, and that's where things get a little bit more interesting. Okay, so there's one more thing we want to do. We've got a handler at this point to be able to accept requests, but we don't have really a way to fire them off. Now, of course, we could use curl on the command line. We could use one of the numerous HTTP tools to inspect network traffic and this and that, but we're kind of working with raw JSON objects. It's not too much fun. Now, luckily, one thing that async GraphQL provides us with is a GraphQL playground. Now, this is very typical, very common in the JavaScript ecosystem. So you may have come across this before, but it's also built into this library. So we're going to get this GraphQL we'll call it GraphQL playground. So these are all handlers in much the same way health is a handler. This is something that Warp knows once it's a user has requested something from this endpoint to fire it off to the handler. So we're going to do the same thing and build a GraphQL playground. So we're going to say warp and path, and this time let's host that on playground. So we've got these two distinct endpoints. So we're going to map any requests that we get back from that, and we're going to send back a response. Now, the response this time is coming from Warp, okay? So we're going to get that from within HTTP response. So that's why we named this one slightly differently, okay? So we're going to say response builder. So this is going to build up a response for us. And we're going to use a header here that says content type, and this is going to be text HTML. And the reason it's going to be text HTML is because this is actually going to return the playground. And the playground is provided to us out the box by Async GraphQL, and it contains all the HTML and JavaScript pieces and things like that. So that's what we want to return back. So we'll say that the body of that should be all that stuff I've just mentioned. So where do we get that from? Well, there's a convenience method called playground source that we can grab from Async GraphQL. So it's built in. We can say HTTP and we'll grab playground source. And we use that and we just leave it to Async GraphQL to basically bundle that up, figure out what should be sent back to the client. Okay, so within that, we actually need a configuration because there's going to be parts of this that get merged into that injected JavaScript and HTML for things like where we're hosting this GraphQL endpoint. Because we can configure this in userland, we also are able to configure this within the playground source. So what I'll do is I'll jump back up, and up here we'll add these braces around the HTTP because we're going to grab a second thing here, and this is going to be the GraphQL playground config. So we'll open that up, and what we'll say here is that we want a new configuration, and you can see from the name of the parameter it takes, it's going to be the endpoint. So we'll just point that to GraphQL. Okay, and we'll save that. And I think that's looking good. So really all at this point we need to do is wire together all the routes. So we've got this help box thing at the moment. So that's the only thing that that would currently be returned. So what we do in Warpland is we say that we want to return health if someone goes to this thing, or one of the other handlers that we've created. And so we're going to say the GraphQL handler first of all, or it could be GraphQL Playground. This is all dependent on the route that the user has requested. And in any case, it's going to be box. We don't exactly know the shape of this thing. So as you can see, if we hover over this, we've got the red squigglies. There's a few different things we need to add there to get this to compile and to match that against a box filter. So I'll just make sure we've got all this stuff up here. And to make this slightly simpler, what I'll do is I'll just combine these warp lines. So we'll save that. So what have we got at this point? We've got box filter, we've got reply, we've got rejection, we've got response, and we've got reply. Okay, that's looking fine. So what is it that we're missing up here? So in GraphQL, async GraphQL, we have the playground source, the request, the schema, that's looking good. In Warp, we're pulling in this future X thing. I think this just came in automatically. We don't actually need that. Async GraphQL Warp, we have the response, we have this infallible thing, we have the JSON, we have the help. Okay, so I've taken away the future extensions, and it looks like there was a little bit of conflict there with the box method from that versus the box method that we need to send back from Warp. So getting rid of that has clarified things, and it looks like we're good to go. Okay, so at this point, I'm going to compile the application. I believe we've got everything we need. So let's just see if this works. So we will go back to the terminal. I won't do the terminal update at this point. We'll just, as before, Rust log, debug, cargo run. I'll pause the video and I'll see you when it's done. Okay, we're back, but we see an error. Type schema query is private. Okay, so if we go back here you can see that this is a struct query. Now, although it looks like it should work because the modifiers work within the schema module, and it seems that we're just returning this thing from here, because this is actually used to build the schema, and because merged object is injecting boilerplate and ensuring that this is available to whatever scope it is that we're using. In this case, this happens to be the server module. We need to make that public. So hopefully this runs this time, and you can see we've got the bin at the end, which is always a good indication that things are running. And so let's see what happens. I'll wait for that, and off we go. We have the server now running. Okay, so I'm going to copy that. I'm going to head over to the web browser again and paste that in. And as before, we still have that health handler at the root of the application. So that's perfectly fine. But now we have this / GraphQL, which if we run that, we'll see HTTP method not allowed, because remember, this is post. It's going to take post requests. But the real reward from this work is going to be / playground. And this looks a lot nicer. So if you're not familiar with this, this comes from a JavaScript land. It's very common if you used libraries like Apollo or many of the GraphQL libraries in JavaScript, be they server-side or front-end client-side. You've probably seen this or something like it. There are a few different versions of this available. And what we can do on this left side is we can begin to write a query and execute that against the GraphQL endpoint, which you can see is pre-filled here. If we hit play, on the right side, we're going to get the response. And also on this side, on the docs, you can see we can actually introspect what is available to us. So you can see a query that's available that's health, that is going to return Boolean. The bang character or the exclamation mark at the end means it's going to, that's a required response. It's definitely going to give us a Boolean. It's not an optional Boolean. This will not be null. It will be true or false. And if we click on that, remember before we used the doc comments in order to annotate this with a description that's made its way all throughout to this application. If you click on the schema, you can also see the GraphQL SDL for what we've created on the back end. So it's generated all that stuff for us. We haven't had to do anything. It's a very declarative language. Okay, so let's actually execute a query and see a response back. So you can see we can open if we want, we can do query, we can do it that way and open this up, or we can just, as a convenient shorthand, we can just use kind of the object style, and we can say health. Okay, so this is the one field we're requesting at this point. If we hit play, we get true. Now, not too many interesting things happening here. Well, think about the stuff in the background that we haven't had to do. Okay, so we haven't had to definitively handle a JSON payload. We haven't had to serialize that back to a format that async GraphQL understands. We haven't had to provide the SDL in order to turn this into something that Rust can understand. We haven't had to provide endpoints for documentation. It's done all of that stuff for us. And so when we request health and hit play, it's going all throughout this this graph, shape of this graph, get into the health query. It's knowing that there's a field available called health, and it's returning that Boolean. And it's doing all of that for us. So from this point on in the course, it does start to feel a little less boilerplatey and a little more closer to the business logic that's going to make up this application. So in the next video, we're going to expand on this. I'm going to show you how we can stitch together another query type into our main query, but also start to take parameters from the user and use that information in order to inform our response. So we're getting already a very type-safe API that we can deploy to production. And in terms of being type-safe, look what happens. For example, you can see if I've misspelt this, I've missed the last character, we get the indication there, cannot find field, health without the H. Did you mean health? Yes, I did mean health. And if we hit play, you can see unknown field. So we've got those helpers as well. built in. So let's go over to the next video and let's start wiring up some input from the user.